So back in 1960, there's this young astronomer, Frank Drake, and he points a radio telescope at two nearby stars and basically just listens. Doesn't matter which frequency, right?
Wow.
Wrong, actually, because he tuned to one very specific spot on the dial, 1,420 megahertz, which, if you're not familiar, happens to be the frequency where hydrogen, the most common element in the entire universe, naturally hums. And I'll get to why that matters in a second. Because Drake's reasoning here, and honestly, this is one of my favorite bits of SETI history, was that if there's some civilization out there trying to get noticed, they'd presumably know that every other civilization with radio telescopes is eventually going to stumble onto hydrogen's signature too. It's kind of universal, right? So that's where you'd point your transmitter. That's where you'd listen. This became known as the water hole, this quiet stretch of spectrum between hydrogen and its chemical cousin hydroxyl, which, kind of poetically, together make up water. And look, I know that sounds almost too tidy to be real science, but that was basically the logic, and it stuck. And for over 60 years, that's pretty much exactly what happened. Project ALMA, the Allen Telescope Array, Breakthrough Listen, basically every major SETI search you could name aimed its ears at that same narrow band, somewhere around 1.42 to 1.66 gigahertz. It became so foundational that most people, if they've even heard of SETI at all, probably just assume that's simply how this works. That's where you'd find them, if there's anything to find. Except now there's a new study, presented this year at the Royal Astronomical Society's National Astronomy meeting, and it basically argues we've been listening to an almost embarrassingly small slice of what's actually out there. And the researcher who found this, interestingly enough, wasn't even trying to find aliens when she started. So here's the assumption, and it's been baked into basically 6 decades of searching at this point. Intelligent civilizations would broadcast, and we should listen, in the waterhole, because it's the obvious meeting place. Quiet, symbolic, mathematically elegant, all of that. And to be fair, it's a genuinely good assumption. It's also, as it turns out, a really narrow one. The waterhole sits between 1.42 and 1.66 gigahertz, which sounds like a decent chunk of spectrum, until you realize the usable radio spectrum stretches across hundreds of gigahertz. So, I don't know, imagine searching one bookshelf in a library the size of a continent, and then just deciding the book you wanted doesn't exist because it wasn't on that one shelf. That's kind of what's been happening here. And that's where Louisa Mason comes in, a PhD researcher over at the University of Manchester. And instead of applying for brand new telescope time, which is the usual extremely expensive way these things get done, she basically just went digging through an archive instead. Specifically, the archive of ALMA, the Atacama Large Millimeter/Submillimeter Array, this collection of radio dishes way up in the Chilean desert. And ALMA wasn't built to hunt for aliens, to be clear. It was built to study things like star formation, molecular clouds, that kind of astronomy. But Mason realized ALMA's archive was just sitting on years of data nobody had re-examined for this purpose. And that data happened to cover a part of the spectrum SETI had essentially never touched. So she pulled 4 archived observations, focused on 2 narrow windows inside what's called ALMA's Band 3, centered around, I believe, 90.6 and 93.2 gigahertz, which, just to put that in perspective, is well over 50 times higher in frequency than the waterhole. This is a stretch of the millimeter and submillimeter spectrum that, and this is basically a direct quote from Mason, remains almost completely unexplored for SETI. Nobody else is currently searching there. Not one other instrument on Earth is even pointed at that band looking for artificial signals right now. And this, by the way, was the first SETI survey ever conducted using ALMA. First one, ever. Now here's the part that would kind of deflate most stories, but I actually think it makes this one stronger. She didn't find aliens. No candidate technosignatures turned up above her detection thresholds in either of those windows. But, and I think this is the actual point, that's not really the discovery. The discovery is that this entire, enormous stretch of spectrum, one that basically every SETI program has ignored for 60 years, is not only searchable, it's already sitting in archives waiting for someone to go back and look. We hadn't even opened the door to the room right next to the one we've been checking. And there's a second piece to this that I think makes the whole argument sharper. A companion study, and this one's modeling something researchers call stellar bycatch, found that past SETI surveys have accidentally covered way more stars than anyone had counted before. The earlier published number was something like 288,000 stars ever searched. But the new modeling suggests the real number, once you count every star that happened to drift through a telescope's wide beam without anyone realizing it, is over 6 million. So that's roughly 21 times more than we thought, which again is a pretty wild undercount to have been carrying around for this long. Put those two findings together, and honestly, the whole picture kind of flips. It's not just that we've been listening in the wrong slice of the dial. It's that even within the slice we have been checking, we've apparently been undercounting our own progress the entire time. Now, it's worth pausing here because I don't want this to sound like high-frequency SETI was just sitting there, obviously waiting to be tried, and everyone was too lazy to do it. There's a real reason 6 decades of searches avoided this range, and it's not just habit. At the water hole's low frequencies, a signal's drift, basically how much its exact pitch shifts as a transmitting planet and a receiving telescope move relative to each other, creeps along at around 4 Hz per second, pretty manageable. But scale that up to 90 gigahertz, and that same physics gives you a drift rate around 400 Hz per second, 100 times faster. So a signal that would sit neatly in one channel down at low frequency just smears out across a much wider swath up here, and catching it needs way more sophisticated signal processing than the water hole ever required. And on top of that, band 3 isn't some nice, quiet, empty stretch the way the water hole basically was by design. It's crowded, full of natural radio emission from interstellar molecules, carbon monoxide, hydrogen cyanide, diazonilium, all humming away at frequencies close enough that picking an artificial signal out of that noise is genuinely hard. So yeah, this isn't really a story about 60 years of scientists being lazy or careless. It's more a story about a frontier that was technically brutal to work in, and someone who finally built the tools or borrowed the right archive to go try it anyway. And if you step back, I think the shape of this story is honestly bigger than one frequency band. Every time we've assumed we knew exactly where to look, for life, for signals, for habitability, period, the universe has this habit of turning up somewhere just outside the frame we drew for it. Life around deep-sea vents that get zero sunlight. Habitable zone thinking stretching out to cover ice-covered moons with oceans hidden under kilometers of crust. And now, apparently, the search for intelligence itself, quietly admitting that 60 years of obvious answers may have only ever covered a sliver of the actual question. Mason's survey didn't find a signal, to be clear, but it did something SETI arguably needed for a while now. It cracked open a door nobody else was even trying to open, using data that had been sitting there the whole time. And if there is a civilization out there transmitting somewhere in the millimeter band, in some stretch of sky ALMA already recorded years ago for a completely unrelated reason, well, the evidence might genuinely already be sitting on a hard drive in Chile, just waiting for someone to go back and listen to it properly. We didn't need a new telescope for this one. We just needed someone to ask a different question about the one we already had. If this changed how you think about the search for something out there, that's exactly why this channel exists. Subscribing costs nothing, but it's what lets us keep chasing stories like this one. If you want to see where this search goes next, hit subscribe. And if this one actually made you stop and think, a like, a share, or even just a comment with your own take genuinely helps more than you'd guess. It's what lets us keep making videos like this.